Ever wonder who wrote the rulebook for modern computing, long before sleek laptops and smartphones? One man was laying the very foundation of the software we use every day. In the 1960s, a brilliant mind began a project so ambitious, so comprehensive, that it continues to shape the digital world. This is the story of Donald Knuth, a name synonymous with algorithmic perfection, a true titan of computer science often hailed as the father of algorithms. His work isn't just a historical footnote, it's the living, breathing DNA of programming, a legacy that started with a single, monumental idea. Donald Knuth is perhaps most famously known for his magnum opus, The Art of Computer Programming. This isn't just a book, it's a multi-volume encyclopedia that has become the definitive reference for programmers and computer scientists worldwide. He began writing it in 1962, originally intending it to be a single volume. However, the sheer depth and breadth of the subject matter quickly became apparent, and the project expanded into a planned 7-volume series. To this day, it is considered the gold standard in the field. What makes it so enduring? Knuth didn't just list algorithms, he dissected them with mathematical rigor, analyzing their efficiency, their strengths, and their weaknesses. He provided a level of detail and clarity that was unprecedented. For generations of students and professionals, the art of computer programming has been the ultimate guide, the final word on the fundamental principles that govern how computers solve problems. It's so respected that Bill Gates once famously said, "If you think you're a really good programmer, read Knuth's Art of Computer Programming. You should definitely send me a resume if you can read the whole thing." Even though the first volumes were written over half a century ago, the core concepts and analytical frameworks they established remain profoundly relevant, a testament to Knuth's incredible foresight and intellectual prowess. Beyond his encyclopedic work, Knuth's direct contributions to the algorithmic landscape are immense. He is credited with creating and formalizing some of the most fundamental sorting and searching algorithms that form the bedrock of countless applications. Think about how a social media feed organizes posts, how a search engine finds a specific web page among billions, or how a database retrieves a customer's record. At the heart of these operations are sorting and searching algorithms, and many of the classic, efficient methods trace their lineage back to Knuth's work. He didn't just invent algorithms, he pioneered the very science of analyzing them. He introduced the concept of asymptotic analysis, using Big O notation, which has become the universal language for describing an algorithm's efficiency. This allows programmers to predict how an algorithm will perform as the amount of data grows, a critical consideration in designing scalable and robust systems. His meticulous analysis of algorithms, like quicksort, and his development of structures like the B-tree have had a lasting impact, influencing everything from operating systems to database management and beyond. But Knuth's genius wasn't confined to the abstract world of algorithms. He was also a master craftsman of digital tools. Frustrated with the poor quality of digital typesetting available in the 1970s for the second volume of his book, he decided to solve the problem himself. The result was TeX, a revolutionary typesetting system that gave authors and publishers unprecedented control over the appearance of mathematical formulas and complex text. Unlike word processors that hide the underlying code, TeX is a markup language, allowing users to define the document structure and layout with precise commands. This level of control made it an instant favorite among academics, scientists, and engineers who needed to produce papers and books filled with intricate equations and symbols. He followed this up with Metafont, a system for designing fonts algorithmically. Together, TeX and Metafont transformed scholarly publishing. Even today, in an era of sophisticated graphical interfaces, TeX and its derivative, LaTeX, remain the standard for producing scientific and technical documents, prized for their stability, portability, and the sheer beauty of their output. This single-handed creation of a professional-grade publishing system perfectly illustrates Knuth's philosophy. When faced with a problem, understand it completely and build the perfect tool to solve it.